if you were standing under a hydraulic press that's slowly squishing you? What would it feel like? And how long would you survive? When people imagine danger, they usually picture something fast. A crash, a meteor, an anvil falling down. These are impacts. Energy arrives all at once, does its damage, and leaves. But there's another kind of danger that doesn't rush. It shows up slowly and then refuses to go away. That danger is sustained pressure, and the clearest demonstration of it is the hydraulic press. To understand why a hydraulic press is so strong, we have to look at how it uses liquid. A hydraulic press is a machine that uses oil and pistons to multiply power. It follows a scientific rule called Pascal's law. This law says that if you push on a liquid in a closed space, that push travels everywhere in the liquid equally. The most important thing to know is that liquids cannot be squished. If you have a bottle full of water and you try to squeeze it, the water doesn't get smaller. It just pushes back against your hand. A hydraulic press uses this pushback power. Inside the machine, there's a small pump and a large cylinder. The pump pushes oil through a thin pipe into a much wider area. Because the oil can't be compressed, it has to move the large metal plate downward. Because the area of the plate is so much bigger than the pipe, the force is multiplied. It's like a giant lever made of liquid. Industrial presses are built to be very heavy and very stiff. They're usually made of thick iron or steel so that they don't bend while they're pushing. They can be controlled so precisely that they can move just 1 millimeter at a time, but with enough power to flatten a diamond. So how much force does a hydraulic press produce? Hydraulic presses are usually rated in tons, which is an inconvenient unit because humans are very bad at imagining tons. So here's a couple comparisons. A 10-ton press. This is like having 5 large pickup trucks stacked on top of you. A human bone can technically hold a lot of weight if it's standing straight up, but 10 tons is already much more than the body can handle. A 100-ton press. This is a common size for a small factory. This is the same weight as 70 mid-sized cars. If this weight were placed on a table, the legs of the table would likely snap instantly. A 5,000-ton press. These are used to make parts for airplanes. This is like taking the entire weight of a Navy destroyer ship and putting it on a single spot. To a 5,000-ton press, a human bone is no harder to crush than a crunchy leaf. Now imagine an evil scientist has put you laying down upright beneath the press with the flat plate descending onto your chest. When the metal plate of the press first touches your skin, the very first thing you feel is the temperature. Industrial plates are usually made of cold, polished steel. Because the surface is perfectly flat, it touches a very large area of your skin all at once. Your skin is covered in tiny sensors called nerves. Some nerves feel pain, some feel heat, and some feel pressure. The pressure sensors are called mechanoreceptors. A needle activates a few nerves. A flat hydraulic plate activates thousands at once. Instead of sharp pain, the brain gets a simpler message. Everything is heavy now. As the press moves down by millimeters, compression begins. Because your body is mostly water, and water can't be compressed, soft tissue is forced sideways in a process called lateral extrusion. Your skin stretches tight, stretch receptors spike, and this is the moment the body realizes something is very wrong. As the press continues to move, the weight goes from heavy to overwhelming. This is where the human nervous system starts to change how it works. Usually, pain is a useful signal. It tells you to move your hand away from a hot stove. But in a hydraulic press, you cannot move away. Your brain receives so much information from so many nerves at once that it enters a state of sensory overload. Think of your brain like a computer. If you try to open 1,000 programs at the same time, the computer will freeze. Your brain does something similar. When every nerve in a limb or your chest is sending a maximum pain signal, the brain can no longer tell exactly where the pain is. Instead of a sharp feeling, the sensation turns into a massive, dull throb or a feeling of heat. This is also where stress hormones like adrenaline flood your body. Your heart rate goes up and your breathing gets fast. Your body's trying to get ready to fight, but since there's nothing to fight, this extra energy actually makes you more sensitive to what's happening. However, because the pressure is so high, the nerves eventually get squished so hard that they stop being able to send signals at all. This can cause a strange numb feeling, even though the injury is getting worse. As the press continues inside the body, your body parts fail in a specific order. Your veins and arteries are like soft rubber hoses. They're full of blood, which is a liquid. As soon as the press starts pushing, those hoses are squished flat. This is the first major problem. When blood vessels are squished, blood can no longer flow to your heart or your brain. This causes a backup of pressure in other parts of your body. If the press is on a person's chest, the most dangerous part isn't the bones breaking, it's the breathing stopping. To take a breath, your chest has to grow bigger to let air in. The hydraulic press is a physical wall that says the chest cannot grow. Even if your mouth and nose are open, you can't pull air into your lungs because your muscles aren't strong enough to push back against the machine. This is called mechanical asphyxia. Under a press, bones don't usually snap in half like a pencil. Instead, they undergo something called comminution. This means they break into many tiny pieces. Because the press never stops pushing, it drives these bone fragments into the muscles around them. So how long would you be awake during this process? The answer is not very long. Your brain is the control center for your body, and it needs a huge amount of oxygen to stay awake. It gets this oxygen from your blood. As mentioned before, the press squishes the blood vessels and stops the lungs from working. This means the brain stops getting its power supply almost immediately. When the brain runs out of oxygen, it undergoes hypoxia. This happens in stages. Stage 1, dizziness. Within about 5 seconds of the chest being squished, you would feel very lightheaded. Stage 2, tunnel vision. Your eyes need a lot of oxygen to see. Your vision would start to get dark around the edges until you could only see a small circle in the middle. Stage 3, blackout. Within 10 to 15 seconds, the brain can no longer keep the lights on. You fall into a state called unconsciousness. At this point, you're no longer there. You can't feel pain, you can't hear, and you're not aware of what's happening. The body is still there, but the person is asleep. The brain has a built-in emergency mode. When the body experiences a massive injury, the brain releases chemicals called endorphins. These are like the world's strongest natural medicine. The goal of these chemicals is to stop the body from going into shock from the pain. They can make a person feel floaty or detached. Combined with the lack of oxygen, these chemicals make sure that the brain stops processing pain signals. This is why many people who survive bad accidents say they don't remember the pain. They only remember a feeling of being very tired or confused. The brain simply stops recording the pain level because it's too busy trying to stay alive. So people often think that being crushed would take a long time, like in a movie where people have whole conversations while trapped. In real life, physics moves much faster. Here's your timeline for getting killed by a hydraulic press. 0 to 2 seconds. Contact. You feel the cold metal and the initial weight. 2 to 5 seconds. The pressure reaches the point where you can no longer breathe or move. Adrenaline spikes. 5 to 10 seconds. Structural failure begins. Bones begin to break, and the brain starts to run out of oxygen. 10 to 15 seconds. The gray out begins. You lose your vision and ability to think clearly. 15 to 20 seconds. Total loss of consciousness. The brain shuts down. Even if the machine continues to move for another minute, the person involved only experienced about 15 seconds of it. In the end, the brain gives up first and the experience stops. After that, the press just keeps rearranging your body till it's mush. Luckily, hydraulic presses only do this when we turn them on. So let's hope they never become sentient in the future.